Dear friends, for today's Shanka Samadhan, I have a question from a student, Dolly Day, and she is in class 9th, and she writes, in volume 1 mechanics, I am getting confused about centripetal and centrifugal force. From outside, only centripetal force is acting towards center, but inside the car, turning car, why we feel centrifugal force pushing us outside? Is centrifugal force real or fake? So that is basically the question. Why we feel that someone is pushing us outside, towards outside when we are in a turning car. And this force apparently which pushes us outside, is it there or it is something else? So let me start from a very basic, from experience through childhood. We have learned, and later in our textbooks and classes, that to start a motion or to increase the speed of a particle or to decrease the speed of a particle or to turn its direction of motion, a force is needed. Without force, if something is moving, it keeps moving in the straight line path, or if it is at rest, it remains at rest. Not only that, we learned it through Newton's first law of inertia, we learned it through our own experience from the very, very beginning. So it is built in our brain that if there is something is turning, then there has to be some force. Or if something is going in some other direction, starting in that direction, there has to be a force. So that is that keep in mind. Most of the time this law of inertia is felt in the nature, because what we are using is inertial frame of reference. The frame of reference of earth, of ground, is very good inertial frame, not perfect but very good inertial frame, and we experience everything in that frame. So that is how our thinking is tuned. Now coming to the rotational motion of the frame, if we are in a rotating frame, my frame is rotating, my XYZ axis are rotating, and I am from that frame, from that origin, from that axis, trying to analyze the motion of other things. So let me give you a simple example. Suppose I have a disc, and this disc is made to rotate. This disc is made to rotate by some motor or something, and someone is using x-axis drawn here, y-axis drawn here, and z-axis drawn here on the disc. So as the disc rotates, these XYZ axes are also rotating, and we say that we are using a rotating frame of reference. Now, rotating frame of reference is not inertial. Law of inertia, Newton's first law, will not hold. Just see how. Suppose outside this, in the room, there is a table, and on that table something is kept. Some block, some mass, some box, something is kept there, just kept there. So we understand that, okay, it is here. It is here because there is no resultant force on it. There are forces, gravity, weight is downwards, and then the table is pushing it upwards, and these two cancel with each other. There is no horizontal force, and therefore it is at rest. But if you use this frame, if your observer is sitting with this frame, and this observer is looking at this block, what will the observer see? We will see that this block is going in a circle in opposite sense. At certain time it is here in front of the eye, in front of the x-axis, and later on when this turns, it's no more along the x-axis, on the x-axis. So it has turned. So this, as seen from here, as seen from this frame, this block together with the table, this whole thing is going this way. Now our brain is tuned. If something is changing the direction of motion, a perpendicular force must have acted. So with that mindset, we will say that okay, this block is now experiencing a force and that is turning it. There is a resultant force because the velocity is changing. The direction of velocity is changing. So our brain says that, okay, yes, there must be a force. But there is no force. There is no force. The only force exerted is by the earth and by the table. And then these are vertical. And it is going in a horizontal circle. So these kind of problems will occur when you will use non-inertial frame. You feel that there is a force which is turning it, or which is accelerating it, or which is decelerating it, but it is not there. Why do we legalize that? Why do we define such forces? Such forces which do not exist, but our brain perceives that they exist. They are known as pseudo force. Right? They are known as pseudo force. And we legalize it, we use it to our benefit, to understand it, the mathematics better, or make the mathematics simpler. And we use our own skills of using inertial frames. Okay? And what is that? That if you are using a non-inertial frame, it could be a rotating frame or it could be a linearly accelerated frame also. So if you are using this non-inertial frame, then F is not equal to ma. F is not equal to ma. Mass time acceleration is not equal to the force. If it is not, that means if you calculate this quantity, this is not zero, right? If F is not equal to ma, then this is not zero. If it is not zero, it is something. It is something. Let us call that something as PS. And PS, you understand, is for pseudo. Whatever is left, MA is not equal to F because we are using non-inertial frame. And then MA minus F is not zero. And if it is not zero, it is something. And that something, we call it FPS. So what happens? Your mass times acceleration is F and plus this FPS. It's purely a term. It's purely a quantity which I get by subtracting F from MA. And I am getting that quantity non-zero because I am using non-inertial frame. So it's not a force, but it has a dimension of force. This is force. This has a dimension of force. This has a dimension of force. This also has a dimension of force. Now, make two mistakes. Make two mistakes. One, try to use Newton's law in non-inertial frame, which is wrong. In non-inertial frames, Newton's laws are not applicable. Make a mistake. Try using inertial frame equations in this non-inertial frame. That's one mistake. And the second mistake is treat this as a force acting on the particle. It's not there. It's not a force. No one is exerting this force. For this force, I can always tell, okay, this force is exerted by the table or by the earth or by some surface or something, some spring, some string. So I know who is exerting the force. But for this, you don't find any source who is exerting this force. It's not there. But you assume that it is there. Second mistake. If you make these two mistakes, what will happen? You have an equation like mass times acceleration is equal to total force. You are using this as a force, actual force, and this is anyway actual force. So this is the total force, and then mass times acceleration is equal to total force, and all your methods of solving problems in inertial frames will be applicable. So that is why we use these forces, these fake forces, as something which is actually existing, as if it actually exists, and it adds to the real forces. So this is the background. Now another thing that you ask, that when we are in a moving, turning car, why do we feel, if the force is fake, then why do we feel that there is a force? Again, it is our own training to the brain. If we see something accelerating, we presume that there must be a force. So what happens if you are in the car and the car is turning? Suppose you are here, okay, and suddenly the car is going straight and is going in this direction. And now the car is turning, so you are also sitting there, but you were going this way. Now, if you are going this way, no force, suppose there is no force and you are going this way. So your distance, now the x-axis reaches here and then you are here. So or you are still on the x-axis, but then the distance has increased. That means you have moved on the x-axis towards outside. And if you do that, you presume that someone is pushing you in the direction of x-axis, because you were calmly sitting here on the x-axis when the car was going straight, and all of a sudden you find that my x distance has increased, because you are still sitting there. Other forces are there, friction, etc., and the normal forces from the back and everything. So we are still sitting there, but the parts which are somewhat loose, they will move in this direction, and you will find that someone is pushing me in the x-axis in the outward direction. Outward now is your x-axis itself, because you are using that frame. So that is how you feel that someone is pushing you outside. No one is pushing you outside. But since you are using these axes, you feel that, okay, my distance from the origin has increased, and therefore I am accelerated, and therefore there must be a force. So that training of working in inertial frame of reference causes this.